So hey guys, we are back with another video, and this video is about Gemma-3, the latest model by Google. So I think from the past 1 year, Google has been trying to outperform other companies like OpenAI, Microsoft, Meta in the domain of this LLM, right? But recently, in the past 4 to 5 months, we have seen really good improvements from Google, especially when it comes to Gemini and Gemma. So recently, I saw an article on LinkedIn, right? It was stating that Google has done a partnership with Apple, that Apple is going to use all the features of AI from Google, not OpenAI. They did a comparison, benchmark, and internally, and Apple concluded that Google is far better than OpenAI in some cases, the use cases that they are looking for. So clearly, we are seeing some good products from Google now, finally. And this video is going to be about how Gemma 3 is different from the previous Gemma 2, and what are the results that it is giving us, that we can say that okay, they have done something different this time, and the results actually look promising. Okay, so let's get started. Now, coming to the 4 to 5 key points of Java 3 that we are going to discuss, I have the paper with me here, and I am going to read some of the lines exactly from the paper so that you guys can know that what the authors and the team is trying to convey here. Okay, so they released Gemma in 4 parameters. First is 1 billion, second billion, 12 billion, and 27 billion. It is, it has the functionality of multimodality. It can produce images as well as text. Okay, it has a 128K long context. I mentioned it twice, I guess, because initially the 1 billion model, it is of 32K context, right? And it is multilingual. That's the best part. It has used sliding window attention along with the global attention. They have come up with a ratio of 5:1 as the final one. They have done a lot of research on this, and even 7:1 was working, but they went with 5:1. Okay. Now this is one of an example. So you can see they have uploaded a photo of an invoice, and then they have asked only had sliced meat, how much do I need to pay, including a 18% tip. So it has done the mathematics, and then it is able to say 43.07. So it's really good, right? We are not expecting the model to fail here because it's a very simple image and a very simple question. So these simple things, at least in multimodality part, the model is performing decent. Okay. Now, coming to parameter count and everything, the vision encoder here, right? It has only 417 million parameters, mind that. And the embedding parameters, you can see in 27 billion is 1416 billion, right? And non-embedding is 25600. So if you add it all up, you'll get it right. So yeah. Now coming to the part where everything lies is pre-training data. If you see, they have used 2 trillion tokens for the 1 billion model. Now anyone who came to this video right after llama 2 would be surprised that okay, what about the scaling laws and everything. But I think we saw a bunch of changes in scaling law post llama 3.1, and they used 4 trillion tokens for 4 billion, 12 trillion for 12 billion, and I was expecting 27 trillion for 27 billion. I don't know why, but they used 14 trillion. Now coming to the increase in the tokens, right? They account for mix of images and text that is used during pre-training. Just mind this, guys. When we say this 2 trillion tokens, it also includes the vision part also. Okay, because you have to describe the image and everything, right? Correct. Now tokenizer, they have the same tokenizer as Gemini 2.0, a sentence piece tokenizer with split digits, preserved byte size and byte level encodings as usual, the same as Gemini 2, right? And they have a vocabulary size of I think 262K, right? Yeah, 262K. And the tokenizer is also very stable for multilinguality, right? Because that is one of the core aspects that they are selling with this model, that okay, this model is really good in multilinguality. Now they have used TPUs here for the whole training purpose, and you can see the chips and the data sequence and replica in the charts part. So anyone interested in this can actually go in the paper. They have the whole section on it where they are explaining that how they came up with this compute infrastructure. And I think they have also released this one liner, right? That Gemma 3 is the best model currently, which can be inferred on a single H100, and it can perform wonders, right? So yeah. Now distillation, right? They have used the 256 logics per token from a larger instruct model. They have not told us which model they have used. I can suspect a very good model that can be, I think, Gemini 2.0 Flash maybe, because that model is super good. And yeah, I think they are explaining the whole distillation process, right? The students that teaches distribution within these samples through the cross entropy loss. We already know about distillation, right? So the teacher's target distribution is set to 0, probability for non-sample logits and renormalized. Okay. Now, for the reinforcement learning part, I'm not going to discuss everything in detail here, because these three algorithms, right, bond, worm, and warp, they are they can make a whole video itself of an hour or maybe 2 hours. So they have used this reinforcement learning techniques, and in the paper they have specifically mentioned that this is a very important part of their post training part, because guys, 2025 is an year of post training. We all have, I think, come to a conclusion that okay, pre training is coming, helping us till one extent, but if we want our models to be really good thinking, and the new techniques that are coming up, we need good algorithms of RL, right? So they have used bond, worm, and warp. I think we can have a proper discussion in the next video about what are these three algorithms, irrespective of anyone is using Gemma-3 or not, because reinforcement learning, guys, these algorithms are really important. The way they change policies, the way they are going to divide things, and the reward structure itself is going to be different, right? So yeah, that we can discuss in the next video for sure. Now, this BOS token, right? It is also a very important thing in Gemma 3. They are now forcing a BOS token, and they in the I think example, I think in the next, yeah, this will come to next. I already told you, right, guys, right? 262K vocab size is there, and they are using this start of turn user and start of turn model, right, for the whole purpose of, yeah, turning on that. Okay, you need to start from here, and for both pre-trained and instructed models, right? They are saying that the text start with a BOS token, not be part of the text, because this BOS does not map to BOS token. So you need to first tokenize the whole thing, and at the end add the BOS token. Okay. I think they are telling, right, flags as an option, add BOS is equals to true, and I think same will be applicable on the Hugging Face transformers library. I hope so. They have this enabled there, right? So this is going to automatically add this BOS token when initializing the tokenizer and starting everything. So this is an example, right? You see here BOS token, and then we have everything. Start of turn user, who are you? Similarly, model, my name is Gemma, what is 2 plus 2? 2 plus 2 is equals to 4, something like that, right? So this is really very important. Now, BOS token, I think we have discussed. Now coming to the results part, right? Because everyone is thinking about, are these numbers good? I would say these numbers are actually very good and they are reliable, because I think we all saw what happened with Gemini 1, right? I think Gemini 1.5, I think it happened with that they hyped it up a lot, and at the end when the model got released, we saw, okay, this is not something good, right? So I don't think that is going to happen with Gemma 3, because Gemini 2.0 Flash is a really good model, guys. And if they are able to do that with Gemini, why not with Gemma, right? They have the same team here. You see, Gemma 3 is 27 billion instruction tuned. I think they are getting a yellow score of 31338, and this model has 27 billion active parameters. But if you look at the score of DeepSeek R1, 1360, and active parameters at a time is 37 billion. So Grok 3, guys, this I never thought, Grok is going to outperform every other model in the market, but I think Elon has done that, right? So yeah. Now, coming to the next part, that when you look at the most famous benchmarks, right, MMLU Pro, MMLU, Hidden Math, the facts grounding. So you will see the previous model, Gemma 2, was performing really poor here, 56.9, but now they have increased it to 67.5, a significant improvement, right? A 10% whooping increase in the accuracy. 10.5, I would say. And that's a good increase, right? And similarly, if you see at all the numbers, they're even, I think, competing with Gemini, right? I think in Gemini 2.0 Flash, 77.6 and 67.5 here, and I'm pretty sure Flash is more than 100 billion parameter model, right? So yeah, it's performing really good. I think even more than 500 billion parameter it can be, because Pro, what everyone is expected, it is also a MOE architecture model with more than 800 billion parameters, right? I heard from one of my friends who is at Google. So it can be correct, it cannot be. Now, if you look at the specific domain results, right, you'll see a vision. Obviously, Gemma 2 did not have the capability to for the vision things. But if you look at Gemma 3, right, it's performing really good in all the things. You see, when it comes to the code part, Gemma 3 is performing really good. So I think anyone who is looking to fine tune a model for maybe some coding purpose, or maybe fine tune a model for a specific language, I think Gemma 3 is a really good open source model, especially the 12 billion parameter one, right? Because currently multilinguality is a very important thing in market. Most of the models are not that good in multilinguality, right? So yeah, I can tell that from an example of Indonesia at least, that okay, a lot of models are not that good. Now ablations, right? The main fun part. So this is the global and local ratio for the attention part, right? On the perplexity of a validation set. So you can see the 5:1 ratio was performing good. The 7:1 is also performing, I would say, decent, but for 2 billion one, I think it's not performing that good, right? So yeah. Now coming to the next part, the impact of sliding window size on perplexity on a validation set. So I think everyone know about perplexity, right? We have discussed, made a whole video about cross entropy and perplexity. So if you guys have not watched that, you guys can go and watch it and understand what is perplexity. So I think here the ratio, yeah, they have considered two billion models here, and the ratio with 1:1 and 1:2 to the global layer ratio, right? So yeah, I think sliding window attention is known by everyone, right? We have covered that in the Mistral paper video. What is sliding window attention? No, now coming to KV cache. Guys, one more thing important in this, they have tried to reduce the KV cache here using the attention, the whole attention algorithm, the sliding window and global. They have tried to, reduce that because KV cache was, making up a whole lot of memory space in the whole thing. So during inference with a pre-fill KV cache of 32K, we considered a 2 billion model with different local to global ratios. Now, if you look at the results here, you will clearly see the ratio is going down and down and down, right? So that is what is required. If you see here global, the ratio is of the inference memory in global and KV. It's pretty high, right? KV is taking a lot of cache here, but if you see here at 1:3, right, you will see it's taking only a small bit of cache. The number is 102 for here for sure, right? Now, important points, they have trained from the 32K context, then extended it to 128K context. Everyone should know this. They have used a rope scaling of 8. I think rope is rotary position embeddings. A lot of people already know here. Pan and scale algo was used for vision encoder. I still need to, for the vision part, I have not specifically made a slide because I have not studied it in detail for now, the vision part. But because they have used a fixed resolution of 896 is to 896. Now they are using windowing using inference time to allow other sizes. I think it's fine. Now this is the long context performing of pre-trained model before and after rope scaling. So this is the average perplexity and 4 billion plus long context. If you see here, see guys, the perplexity is constantly decreasing as you go to the context length. Now same thing is happening for 27 billion plus context length. That is good. From 0.62 we have reached, so yeah, 0.5 I think, yeah, for the 256K and 400K I would say, yeah. But for the 12 billion without perplexity, obviously you will see the slight increase here, right? So yeah. So yeah, guys, that was it for the video. I think you guys have understood most of the important points that were required for understanding what is making Gemma-3 bit different and what they have actually included in the technical report overall. So you guys can go and try it on Hugging Face. It's free to use. So, and let me know what are your thoughts about Google and Gemma-3. Are you guys thinking of using Gemma-3 in future for fine tuning for some particular task like multilinguality or maybe something specific to coding? Let me know, guys, and I'll see you in the next one. So thank you and have a nice day.